Hello, good morning, friends.
Berapa?
Good afternoon to all of you, whoever joined in this counseling session. Can you hear me?
Yes, sir.
Anyone?
Yes, sir. Very good. Good evening.
यही प्रॉब्लम हल है ଆଉ ଯେତେବେଳେ ଆସିବ କହିଲ କ'ଣ
Anyone can tell me the last date of assignment submission?
Okay, so there was a network issue. So wait for a minute.
Hello, can you hear me?
Yes, sir.
Yes, sir.
Hello.
Yes, sir. Yes, sir. We can hear you.
Potential calculus
Yes, sir.
and before going to discuss, I'm going for a quick review. What we'll discuss in the last period or in last session. So in the first session, about the basic functions, limit, continuity, and differentiation. And then we are discussing the concept of English numbers.
Your voice is breaking, sir. It's not clear. Your voice is.
This block 4 is exactly divided into 5 units. So here in first unit we have to cover the intermediate plus about the ups and downs, that means increasing decreasing functions and the curvature asymptotes. Finally, we are going to discuss about the calculation. So, ବେଳେବେଳେ ଶୁଣାଯାଉନି। ମାଇକ୍ଟା ଅଛି ଏଠି।
You are not audible, sir.
Actually, network problem. Hello, Haru.
Yes, sir.
Any question?
Excuse me, sir. Hello.
Hello.
Sir, as we got the information.
Have you any question?
Yes, sir. Hello.
Yes.
Yes, sir. As we got the information today,
Hello.
but yes, sir. But the schedule was set already from the 8th of April. So, so how we can understand the block from the block 1?
So block 1 is the basic concept about set theory.
Yes, sir.
Relation functions, which are already you learned in 10 plus 2 levels.
So we got the mail about this class today only, but it has started before.
Hello. Can
Yes,
you hear
sir.
me?
Yes, sir.
And then in block 2 we discuss about the
Yes,
limit
sir.
of a function.
The voice is breaking, sir.
And in block 3 we have discussed about the differentiation. So block 2 is present. Hello.
Yes, sir.
Hello.
Can I continue? Any other question? Can you hear me clearly?
Yes, sir. Hello. Hello.
So let us, we are moving down towards the this particular forms are known as indeterminate forms. And whose examples are given in the right hand side. So here the, or you may also pronounce it as L. Generally we pronounce that where
Your voice
we
is
found
not clear,
intermediate
sir.
forms in the limit.
We cannot hear you clearly, sir. Your voice is
So
not clear.
in the denominator, that you take. So this is a technical issue. Your network is very poor. We are facing some problems.
Now it's audible, sir. Hello. Sir, it's audible, but it's not clear because of your voice is breaking. Hello. Sir, if possible, please arrange the offline classes. Hello. Sir, if possible, please arrange the offline classes as we want to attend the class.
Hello. Now
Yes,
can
sir.
you hear me?
Yes, sir.
So in this session we have 4 times rejoin the session. Audible? Can you hear me?
Yes, sir.
So now let us begin. So we are in the fourth counseling session of calculus BMTC 131 course 4, and here in this block 4, our main focus is to discuss about the application of differential calculus. In application of differential calculus, the first unit is totally dedicated to the intermediate form in limits. So here in intermediate form in limits will appear whenever you find 0 by 0 form or infinity by infinity form or infinity minus infinity form, or otherwise you may also find 0 to the power infinity or 0 into infinity. So these are already listed in your textbook, and whenever you find this kind of intermediate form in limit, so then we have to apply some basic rules to calculate the value of this kind of limits. And to overcome this kind of intermediate forms, we are using generally L'Hopital rule or L-Hospital rule. You may also pronounce it as a L-Hospital rule. So here you may find it in page number 8. In your textbook, you may go to the page number 8, and in page number 8 you will find the L'Hopital rule for 0 by 0 form, or it is also applicable for the infinity by infinity form. So let us talk about this L hospital rule or L'Hopital rule. Whenever we find intermediate form in limit. So here, look at the basic calculation procedure. So here is the statement of the formula. So here, whenever we find 0 by 0 form, that means intermediate form, to overcome this particular limit, we have to take the derivative of the numerator and simply the derivative of the denominator, that is f dash x in the numerator and g dash x in the denominator, and then we are applying the same process of calculation as we follow in the previous calculations. So here the simple first order derivative we have to apply in the numerator as well as in the denominator, but here we have to remember that we are not going to use here the quotient rule of derivative, but
Excuse
directly we are
me,
using. Yes,
sir, as we have not we have not our textbook, please can you share your screen, sir,
I
that we
can
can.
share it, but when I'm going to share it, we face difficulty, network problem, so that was the issue. So in
Sir,
this session,
actually,
we
I
have.
had applied for the hard copy of the study material, so I have no math book. So can you refer me a book that I can use for this a BMTC 131?
You may refer any book from the question level, BSc level, graduation level book,
Sorry, sir.
any book, any standard book, degree level standard book.
11th standard.
Yes, 11th standard you may choose.
Okay, sir. 11th standard book I can refer. No? Okay, sir.
11th
Thank you.
standard contains limit, but it does not contain the intermediate form. But if you are looking for the intermediate form, then
Yes,
it
sir.
is better to go for the 12th class textbook.
12th class start textbook.
Yeah. Okay.
Okay, sir.
So
Thank you.
now let us go down to our calculation steps. So here the steps are very clearly mentioned, and we have to calculate in very basic three steps. In first steps, we have to just check that the fraction given in the limit f of x divided by gx must be in intermediate form, otherwise this L'Hopital rule is not applicable there. And then if that is in intermediate form, that means 0 by 0 or infinity by infinity form, then we can ensure that we are able to apply the L'Hopital rule to calculate the limits. And then very simply we can calculate the derivative of the numerator as well as derivative of the denominator. So here The calculation will be very simple. I'm going to share it. Can you see now the PDF page? Now look at the first example. Look at the first example. Here in the first example, it was written that limit x approaches to 0, 1 minus cos x divided by sin x. So here, when we put the value of x equal to 0 in the numerator, and here numerator is taken a function in the form of f, so it is written like that, f of x equals to 1 minus cos x, and the denominator is taken as the function g, that is gx equal to sin x. Now, if we are using the limit in the numerator, look at the result is 0. And similarly, if we are using the limit in the denominator, again the result will be 0. So here, we found this 0 by 0 or intermediate form. So we ensure that this L hospital rule or L'Hopital rule is applicable, and that is applied in the next calculation. As you can see in the next calculation, it is very clearly mentioned that we are using the first order derivative dy dx of the numerator function, that is 1 minus cos x, and dy dx of the denominator, that is sin x. And according to the derivative formula, the derivative of constant is 0, so the derivative of 1 is written here 0, and derivative of cos x is minus sin x, and that was in the form of plus sin x, and whole divided by cos x, because as we know in the denominator the function is sin x, whose derivative is cos x. So in this way, we are just using the derivative of the numerator and derivative of the denominator. And after calculating the derivative in numerator as well as in denominator, we are again assign the limiting value x approaches to 0. So sin 0 in the numerator and cos 0 in the denominator. So that's why the corresponding value of sin 0 is 0 and corresponding value of cos 0 is 1, and the result will be 0. So this is a simple and easy process to calculate the value of a limit when we found any intermediate form in limits. So this type of examples are given. So let us discuss more examples in the form of so here in example number 5, the function is given in the form of x square in the numerator and sine square x in the denominator. So here we can take the numerator as a function f, that is x square, and denominator is a g, that is sine square x. Now clearly, when we are assigning the value of x equals to 0 in the numerator as well as in the denominator, it will be in the form of 0 by 0, that is intermediate form. And then we ensure that the L'Hopital rule can be applicable here to find out the limit of this particular problem. So that's why, according to the process of calculation of L'Hopital rule, we are using the derivative of the numerator, that is f ds x, and derivative of the denominator, that is g dash x. And very simply, you can see the derivative of x square is 2x, and derivative of sine square x is 2 sine x into cos x. That was by using the chain rule. So now, simple algebraic calculation we may follow, and the expression is given in the denominator, that is 1 divided by limit x approaches to 0 sine x by x, and that is multiplied with the limit x approaches to 0 cos x, and the result will be here 1. So according to the theorem number 1 means, according to the L'Hopital rule, the result is now 1. And this is the simple and easy process of calculation to overcome the situation of intermediate forms in limits. So let us moving towards the next focus point of discussion, that is all about the application of differential calculus. So this is the first application in unit number 1, that is all about the intermediate forms. So now the same L'Hopital rule can be applicable in the form of infinity by infinity form. And here, as you can see in your textbook, it is in the page number. It is in the page number 17. Page number 17, you will find the L'Hopital rule for infinity by infinity form. So here, just we have to ensure that the form of the limit must be infinity by infinity. That means if we assign the value of the point, that is x, numerator gives us infinity value and denominator is also gives us infinity value. So whenever this situation arises, then again we can apply the L'Hopital rule or L'Hospital rule. L as follows. So here, before we are going to calculate by using L'Hospital rule, we must have to ensure that the form must be infinity by infinity form. But the process of calculation will be exactly the same. Process of calculation will be exactly the same means we have to calculate the derivative of numerator and derivative of denominator, and it is the first order derivative. But be careful that we are not using here the quotient rule of derivative. We are just calculating the derivative of numerator and derivative of denominator. After calculating the derivative, same process of calculation we follow. That means again we have to assign the value of the x to get the result of the limit. So let us discuss with the help of the following example. So look at the example number 15. So example number 15, we have the question is limit x approaches to infinity, e to the power x divided by x to the power n, e to the power x divided by x to the power n. So here the result is, so we have to prove that the limiting value of this function is infinity, where condition is given when n is greater than equal to 1. Now in the same process we have to take numerator e to the power x as a function f and the denominator, that is x to the power n, as a function g, and the condition is given to us, that is n is greater than equals to 1. So let us begin to assign the value when x tends to infinity, because when we assign the value of x infinity, the numerator will be infinity, because e to the power infinity is always infinity, and here in the denominator also, as x is infinity, so infinity to the power any value n is also infinity. So that's why we ensure that this particular form of limit is in infinity by infinity form. That means now very simply we can apply the L'Hopital rule to calculate the limiting process. So here, to calculate the L'Hopital rule, if we are calculating the first order derivative in numerator as well as in denominator, so look at in this expression here, we are calculating the first derivative of the numerator, that is f dash x, and the function will be same, e to the power x, and the first derivative of the denominator will be here g dash x. So after calculating first derivative, we can assign the value of x, that is infinity, and we will get the result is infinity, and this result we obtain when n equals to 1. And similarly, the same can be calculated for other values of n. That means when n is greater than 1, you can also apply the L'Hopital rule to calculate this form of expression. So here, look at the expression. It is written that it is clear that the expression is limit x approaches to 0, look at the power of x. So it was written like that, f inside bracket k, that means that is the k number derivative of the function f. Then we are assigning the value of the x is infinity, and the result we got is also infinity. And similarly, in the denominator, as it is a function of x to the power n monomial with power n, we have to calculate the kth derivative. Then, after assigning the value of x equal to infinity, also we got the result infinity. So that's why final for the final output or the final result, we have to calculate nth derivative in numerator as well as nth derivative in the denominator. So if we are going to calculate the nth derivative in the numerator, the basic function, exponential function will be exactly same in the numerator. But whereas in the denominator, since the function is monomial with power n, that is x to the power n, after calculating n derivative, we got simply n factorial. Because after calculating first derivative, it will be n into n minus 1 into n minus 2 into n minus 3, and finally it will be left out as n factorial. So here that will be in the form of infinity, because e to the power infinity will be infinity, and infinity divided by any fixed or finite number is also infinity. So we have calculated in both calculation, that means when n equal to 1, we got the result infinity, and when n greater than 1, also we have got the result is infinity. So this is the way we can use the L'Hopital rule to calculate the limit in case of intermediate form. So now some other algebraic functions are given, some monomial functions are given, and look at the summary of this particular unit. So in this particular summary, we have discussed some other intermediate forms. So here in other indeterminate forms, we have discussed 0 by 0 and infinity by infinity. So whenever this 0 by 0 form appear and infinity by infinity form appear in limit, we can directly apply the L'Hopital rule to calculate the result. But there are some other indeterminate form which are also exist in limit, and these other indeterminate forms are in the form of 0 into infinity or 0 to the power infinity. So let us discuss how we can convert this kind of indeterminate form to 0 by 0 form or infinity by infinity form, and then finally we can use the L'Hopital rule to get the result of the problem. So let us begin with the first example. So here in the example number 26, the function is given limit x approaches to 1, 10 pi by 2 x into ln x is given. So we have to note that here when we substitute the value of x equal to 1, the first function, that is 10 pi x by 2, will gives us value 0, and when we assign the value of x equal to 0 in logarithmic function, the value will be infinity. So here the indeterminate form is 0 into infinity when we are assigning the value of x equal to 1. So let us modify the expression given in the function of limit. So here the basic functions can be expressed in that form of, as we know, tan theta can be expressed in the form of sin theta divided by cos theta. So here we are adopting the same formula, and we represent tan theta in the form of sin pi x divided by 2, all divided by cos pi x divided by 2, and ln x or ln x is as usual same unchanged in as a factor. Now look at the expression. So here the limit x approaches to 1 sine pi x by 2, when we are applying the value of x equal to 1 in the sine function, the result is 1. Now let us try to find the limit of the rest of the function. Rest of the function means the rest of the function expressed in this form, that is log x divided by cos pi x divided by 2. So there is the rest of the function, and very interestingly you can see that here the function is here log x in the denominator, that is ln x, and in the denominator, that is cos pi x by 2. And when you substitute the value of x in the numerator, the result is 0, because we know log 1 is 0. And exactly when we substitute the value of x equal to 1 in the denominator, the value of cos pi x by 2 will be cos pi by 2,
Yes, sir.
and cos pi by 2 is 0, and it is in the form of 0 by 0, that means
Excuse me, sir.
indeterminate form. Yeah,
Sir, how can you know that the ln x by cos pi x by 2 is in 0 by 0 form or it is infinity by infinity form?
you have to substitute the limiting value to ensure that one.
Okay,
Clear?
sir. Okay, sir.
So whatever the limiting value given, here in this question it is given 1. It may be given -1 or 0 or 2 or 1 by 3. Whatever the limiting point is given, to ensure it in the form of 0 by 0, we must have to substitute or assign that value in the function or rest of the function. Clear?
Okay, sir.
Okay, thank you. So now, whenever we find this 0 by 0 form, then very clearly we can ensure that yes, we can use now the L'Hopital rule to calculate the same. So here we are using the same one. The calculation in the form of L'Hopital rule is again the process will be same. That means we are calculating the derivative of the numerator, and derivative of log x or ln x is 1 by x, and derivative of cos x is now minus sine pi x by 2, and using by chain rule we can represent into pi by 2. And again, after calculating derivative, we can assigning the limiting value x equal to 1 to get the result, and the result is minus 2 by pi. So finally, we can now assigning the result of both the limiting value to get the final answer. So here, look at the expression. We have given this question, that is limit tan pi x by 2 into ln x, and that is modified in the form of sine by cos, and finally here we have calculated the product of two functions. The product of first function is sine pi x by 2, and the second function is now limit ln x divided by cos pi x by 2. So that's why the limit of the first function is 1, and the limit of the second function is minus pi by 2. So the multiplication of two results gives us the final result, and the result will be minus 2 by pi. So this is the process we have to adopt whenever we are following the indeterminate form a limit, and basically we have to follow the L'Hopital rule to calculate these results. So this kind of questions and examples are given. So it is advised that please go through each and every examples for better understanding the calculation procedure. Now let us moving toward so here let us look at the summary of that particular presentation of this particular unit. So first we have discussed about the indeterminate form in limits, that means 0 by 0 form or infinity by infinity form. So whenever we find 0 by 0 form or infinity by infinity form, we can directly calculate limit by using the L'Hopital rule. And according to this L'Hopital rule, we have to use the derivative, that is first order derivative in the numerator, and Similarly, same in the first order derivative in the denominator also. And finally, we are assigning the value or limiting value of x to calculate the final result of this of a problem. So here, other forms are already here. If you have book, then please look at the page number 29. Is in page number 29. The second point is the other form of indeterminate form. So here in other form of indeterminate form, so these are 0 to the power infinity or infinity minus infinity and 0 into infinity. So whenever we find this kind of expression or indeterminate form, so our job is to simplify the expression. Simplify the expression means you have to simplify the fraction in the form of 0 by 0 or infinity by infinity form, either by multiplying or dividing some extra function, or we have to manipulate or calculating by using standard formula, as one of the example discussed earlier in this session, that is example number 26. Now, in point number 3, it is the rule. So L'Hopital rule is a rule to evaluate the indeterminate forms appear in limit, and you can overcome this indeterminate form if we are applying this L'Hopital rule. And finally, some other indeterminate forms that can be reduced to 0 by 0 form or infinity by infinity form. And these forms are infinity minus infinity, or 1 to the power infinity, or 0 to the power infinity, or 0 to the power 0. So all forms are known as indeterminate form, and these are basically appear in limits. And whenever you find this kind of basic indeterminate form, you cannot directly apply the L'Hopital rule. But yes, we have to convert or modify all these forms in our DGR form, that is 0 by 0 form or infinity by infinity form. So these are our DGR form. So that means whenever in the form of 0 by 0 or infinity by infinity, we are able to apply the L'Hopital rule to calculate the result of that particular question. So this much all about from this first unit. Then in the second unit, let us see that is all about the. So there are some question and answers given in your textbook. Have you any question? Anyone? So here the next unit is divided to the ups and downs. That means here basically we are going to discuss about the increasing and decreasing functions, and how can we discuss about the increasing function or decreasing function of a function without plotting the graph of the function. So this is the main focus point of discussion in this particular unit. So here we have to do the first derivative test or second derivative test, or we may use the mean value theorem or Rolle's theorem or Lagrange mean value theorem. So these are the main focus point of discussion in the second unit of this session. And here these are the represent under this unit of ups and downs. So let us move towards the increasing or decreasing function, or we can say that ups and downs in functions. So as you can see in this picture of the graph given here, so the graph looks like hills and valleys. So if we are going to compare with respect to a horizontal line, so here we can find the ups. You can see that we have drawn a horizontal vertical line that is parallel to horizontal line. These are small lines. So this indicates the crest, or you can say that the maximum points. Similarly, in the downward, these are the different
Minimum points.
value of the function at a certain point which is restricted to a certain interval, so that's why we are using the word relative maximum, because this particular maximum value of the function is confined in a certain small piece of interval. But if we look from left to right of this horizontal line, our maximum value of the function will be the last one, and that will be known as the maxima or maximum value of the function. So that is also known as global maximum. So again I repeat, we are using here two kind of words. First one is a relative maximum or global maximum or maxima. So relative maximum or relative minimum is the word reserved when the value of the function represents maximum or minimum at a certain small interval. And whenever we find the maximum value of function throughout its domain, then that kind of value is known as the maximum value of the function, also known as the global maxima of the function. These are given in picture format. So look at here some definition of maxima and relative maximum. So here the definition is a function f is said to have a relative maximum at a point x0. So look at the expression here. Here we have the inequality
Hello.
f of x0.
Pranay,
Hello,
can you please mute yourself, please?
hello,
हम लोग किंतल मुंडा आ रहा है
hello. Varadappu, please mute your
इसको वहाँ
mic.
तो क्या होगा कौन खर्चा होगा
Hello,
बोला नहीं
please mute your mic. Hello, Virati, please mute your mouth. So now let us focus in this expression. So here in this expression we have f of x0 is greater than equal to f of x. So this inequality exists for each and every value of x in an open interval containing a point x0. So whenever this condition is satisfied by a function in a certain interval or open interval, then we say that the function has a relative maximum value
Please share your
at that
screen.
certain point x0.
To share your
Hello?
screen.
Hello?
Share your screen, please, sir.
My screen.
Yes, sir.
It was already presented.
Okay, sir. Thank you. Yes, sir.
Okay, there is some technical issue.
Yes, sir. Yes, sir. It's now showing.
Okay, now, so here as we are discussing about the relative maximum, so definition is very simple. Just we have to focus in a single inequality, and inequality is given in the form of f of x0 must be greater than equal to f of x, and this condition is satisfied for all x in an open interval containing the point x0. So whenever this condition is satisfied, then we can say that yes, the function is maximum or have a maximum value, and this maximum value is known as the relative maximum value at a point x0. And similarly, if we alter the expression, that means f of x0 is now less than equal to f of x0, For all value of x in a certain often interval containing the point x0, this kind of value is known as the relative minimum value of the point x0. Now, maximum value and minimum value all together, as we know, it is also known as extremum. So relative extremum means it may be maximum or it may be minimum. And then the definition of critical point is given. So definition of critical point is very simple, and it is written in the form of like that. So a point x0 in the domain of a function is said to be critical point or critical number if its first derivative does not exist, or we can say that the function does not exist at that point. In that case, we can say that the function have a critical point and the point is x0. So again, look at carefully the definition. So here, the first derivative of f at the point x0 is equal to 0. Or we can say that the first derivative of f test at the point x0 does not exist. Or also we can add here, the function may not exist at that point, then also we can say that yes, the point is said to be a critical point. So that was here mentioned here. We may note that. So the point is listed in this particular line. We may note that here, if the function is not defined, that means if we are going to calculate the functional value at a certain point x0 and the functional value is not defined, then also we can say that the x0 point is the critical point of the function. So these are the two definitions, we are the applications of differential calculus. And here in this example number 3, here this example number 3, it was discussed that about the critical points without plotting the graph of the function. So here, the question is to find the critical numbers and the critical point for the function f defined by the polynomial in the form of x minus 2 whole square into x plus 1. And then also it was asking to show these points on the graph of the function. So as we discussed in the definition of the critical point, we have to calculate the first derivative is equals to 0, or first derivative does not exist, or the function itself does not exist at certain points. Then these points are known as critical points. So we are calculating the first derivative of the given function by using product rule of derivative, and we get here 3x into x minus 2. Then to calculate. Now we equating the result f dash x equals to 0. After equating the result, we have got the value of x, and these are 0, the first one, and second one is 2. And then we found that these are the two numbers, x equals to 0 and x
Sir,
equal to 2. These are known as critical numbers. Yes.
sir, for this function, why we have taken the x is equal to 0 and 2? The critical numbers of x are x of x is equal to 0 and 2. Because our
Yeah.
function is there is x minus 2, so we have taken the 2. So why the
We
critical numbers are x is equal to 0 and 2?
Yes, according to the definition of the critical number, as we discussed earlier, the definition suggests us to find out the value of the critical number or the critical point. We have to equating in the form of the first derivative of the given function equal to 0. So here, first we calculate the first derivative of the function, that is f dash. Then we are equating this expression equal to 0. If we are going to solve this equation by equating equal to 0, then we easily get these numbers x equal to 0 and x equal to 2. So that's why these are critical numbers. And according to these critical numbers, the value of the function at 0 is 4, and the value of the function at 2 is equals to 0. And exactly these points are represent in that particular graph of the function. So as you can clearly see, the point 04 is the relative maximum, and the point 20 is the relative minimum of the function at the point 2. So it's the simple and easy process to find out the critical numbers and the relative maximum and relative minimum of a certain function. So now look at the critical number theorem. So here the statement is like that: if a continuous function f has a relative maximum at a point x0 in its domain, then x0 must be a critical number of f. So here again we are we may follow the definition of the critical number. So to do the definition, we can see the statement of this particular theorem. So when a function is continuous and the continuous function has a relative maximum at a point x0, then definitely that particular point must satisfy the definition of the critical point. So that is the main basic idea about the critical number theorem. Again, I repeat: if a function is continuous and having a relative maximum value at a point x0, then definitely you can say that the function must satisfy the definition of critical point at that point x0. So that was discussed in the next example. So I request please go through the examples. So I'm focusing to discuss only the basic few and important points in this particular session. So now look at the absolute extrema. Absolute, or we may say that it is global maxima, or just we may write it as maxima. So here the definition is, look at the same kind of definition. So here the definition is satisfied for all value of x in I. I means the interval in which the function is defined.
Sorry, sir.
Here,
I.
capital I is the interval in which the function is defined. That means I is the domain of the function. Here I is the domain of the function, but previously what was discussed in the critical number definition or the relative maximum definition. In the relative maximum definition, we are following in a small open interval containing x0. So this is the basic difference between these two definitions of absolute maximum and relative maximum. And similarly, we can use the same expression but in less than equal to form. So here we have to focus only this difference. Here the same expression, same inequality, but this inequality or this expression will be satisfied in each and every points in the domain of the function. So that's why this is known as absolute maximum or absolute minimum of the function at that point x0. As now you can see here, this global maximum or global minimum, that is also can say that it is a absolute maximum or absolute minimum. So some examples are given. So now let us begin to discuss about the extreme value theorem. So here the statement is like that: a continuous function f has both absolute maximum and absolute minimum on any closed interval ab. So the proof of the statement is not given, But here the statement is like that. So if a function is continuous in a closed interval, then it must have absolute minimum as well as absolute maximum in that particular closed interval. So this is the main focus point of that particular theorem. So look at this graph, and in this graph, the peaks and depths of the continuous function in a closed interval. So again, I repeat the statement in a simple language. We can say like that: if a function is continuous and defined in a closed interval, then definitely we can say that its maximum value and minimum value, that means absolute maximum value and absolute minimum value, must lies inside the interval. So in the figure, look at that one here. The function is defined from outside of the interval AB. The function is, or the graph is drawn in the outside of the interval AB. But if we focus on the interval AB, if we focus on the closed interval AB, then very clearly you can say that inside that particular interval, the function attains absolute maximum value as well as absolute minimum value in that particular interval. So, some more figures are given. So please go through these figures and functions. Now, look at another example of that one. So if we look at that particular function, this function is defined in two intervals, in the interval from -3 to 3, and again in the interval of -2 to 2. So clearly in this interval -3 to 3, we have maximum value as well as minimum value, and again from -2 to 2, we have maximum value as well as minimum value. But clearly in this particular example, we find that the absolute maximum value and the derivative does not exist at these points. But the meaning is that when we follow the interval -3 to 3, look at these peaks. At these peaks, derivative does not exist. So that's why these two extreme points, these black dots, will not be taken as the maximum value of the function. So that is the main idea about this example. No, time here. So the next, so some examples are given. So there are some applications are also given, which are the maximum and minimum value of certain functions. So in the next session or in the next unit, this is the mean value theorem. There is also the applications of the differential calculus. So Rolle's theorem, and then Lagrange mean value theorem and the intermediate value theorem are the main focus point of this particular unit. So here our time is over, but if all of you are wish, then we will continue up to certain times.
sir, as it is very difficult to understand the problems in online classes is going on, so can you please arrange the online offline classes?
So I cannot arrange. You have to request your zonal coordinator or your IGNOU center.
So wherever where you have to request.
So I am talking from Government College Sundargarh now. IGNOU center, Government College Sundargarh.
Sir.
You may request through mail or through WhatsApp because you have the contact number. I hope because I know we are also facing some problems or technical issue.
Yes, sir,
And
because of technical issues also, and as it is the mathematics problem, so it is very difficult to understand all the units and all the blocks as we are in online classes.
I know, but what can I do? I am also unable. So whatever the platform given to us, and we are fully utilize that one to reach you. I hope in near future the offline classes will be very soon,
Sir,
and we will serve you.
can I change my subjects now?
So I cannot say that exactly. You have to contact your government coordinator or IGNOU center, office of the IGNOU center.
Okay, sir.
Any other question from anyone? Be ready. Be ready. Do you have any question? Hello. Do you have any question from anyone? Otherwise, we are going to conclude today. In our next session, we are going to discuss about these applications of differential calculus. That is all about the Rolle's theorem, Lagrange mean value theorem. Hello,
Please
hello,
explain.
Very Naidu.
Hello.
Hello, Very Naidu. Can you hear me? Do you have any question? Please put on your mic. Naidu, please put on your mic first. Hello.
Yes, sir.
Do you have any
Hello.
question? Oh, yes, I can hear you.
Uh, no, sir. Right now, there is no questions.
I know we are also facing some technical problems, and it is very difficult for me also to explain in front of laptop
Yes.
and to teach mathematics through virtual mode.
So can you please share any some basics problems or basic formulas to go through this from the unit
All,
one?
all are given in your textbook. If you can also download it from your Igno site, or you
Sir,
may
we
contact.
have
Yeah,
downloaded, sir. That is there in the website. This,
yeah, yeah,
uh, sir, one more thing I wanted to ask you. I don't know, but am I
yeah, yeah.
asking
Please,
this?
please.
Sir, actually, I have enrolled for this BSc in December last, I think, 2020. But when is my exam? I have gone to that regional training center, this Bhubaneswar.
Yeah.
But they have gone to that college. College also they didn't say anything, but still
So you have to make a mail to your Igno center, regional Igno center.
I I got a ID card, everything, but I got books also. But usually, when is my exam? I have last 2020 December my enrollment for this
Yeah,
course.
yeah, yeah. So you have to, the confirmation can be given only by the Igno center, your chosen Igno center.
S- Sorry, sir, I'm not getting what you're saying.
You can get your confirmation about your exams from your
Hmm.
chosen Igno center. So whatever the center you have chosen for your study center, they will
Okay.
better guide you. That means
ठीक
the
है.
exact status of your enrollment or your whatever your roll number, registration number, or whatever your
Yes.
papers you have taken, so they will better guide
Okay, sir.
because
And
because because they can assess your database. through your enrollment number or registration number.
Okay, sir.
So
Okay,
can
sir.
you tell us the last date of submission of assignment?
Sorry, I do not have any idea about the assignment submission date, but it should be given through your mail or WhatsApp or whatever the contact number you have given to the IGNO or IGNO center. They will contact about the assignment or whatever it may be about your exams. Okay.
Okay,
Okay.
sir. Okay.
Okay. Thank you all of you for
Okay,
joining this
okay,
session.
sir.
So
Thank you
Thank you.
very much, sir.
for tomorrow we will join. Thank you.
Thank
Thank
you,
you.
sir. Thank
Thank
you
you,
very
sir.
much.